Analysis modeling is about creating data, functional and behavioral models of the system. The respective graphic tools we use for analysis modeling purposes are Entity Relationship Diagram, Data Flow Diagram, State Transition Diagram. The entity relationship diagrams emphasize the data objects and their relationships. The entity relationship diagrams emphasize the data objects and their relationships. The data flow diagram illustrates the functions that the system must perform, and the state transition diagram focuses on the time-dependent behavior of the system. The supporting textual modeling tools provide precise definitions of the meaning of the components and connections. For example, process specification describe textually the functions outlined in data flow diagrams. Control specification describe control features in textual form. So does data description describes the ER diagrams. The figure on your screen shows the components of the analysis modeling. Modeling, that is, data flow diagrams. The data flow diagram is a modeling tool that allows us to picture a system as a network of functional processes connected to one another by flows and data stores. The data flow diagram is one of the most commonly used systems modeling tools, particularly for operational systems in which the functions of the system are of more importance and complex than the data that the system manipulates. Let us see the components of a DFT. Figure on your screen shows a typical DFT for a small system. Before we examine its components in detail, notice several things. It hardly needs to be explained at all. One can simply look at the diagram and understand it. The notation is simple and unobtrusive and in a sense intuitively obvious. The diagram fits easily onto one page. This means two things. Number one, someone can look at the diagram without being overwhelmed, and number two, the system that is being modeled by the diagram is not very complex. The diagram has been drawn by a computer. There is nothing wrong with a hand-drawn diagram. As we can see from the figure, that DFT has 4 components: process, flows, data store, external entities. Behavioral models. Dear students, most software responds to events from the outside world as shown in the figure. An event may also be generated by the system process itself. An occurrence of an event causes the system to exhibit some predictable form of behavior. A behavioral model creates a representation of the states of the software and the events that cause the software to change its state. A state transition diagram, STD, can be used to represent the behavior of the system. For behavioral modeling, we use following steps. Make a list of the different states of a system. How does the system behave? Indicate how the system makes a transition from one state to another. How does the system change state? indicate event, indicate action, and lastly, draw a state transition diagram, STD. The notation used to make a transition diagram is shown in figure. To understand the use of state transition diagram, consider software embedded within an office photocopying machine. The photocopier performs a number of functions. For example, it reads users' input, makes copies, reloads paper, performs problem diagnosis, etc. There are 4 states in which photocopier machine software can be. Number 1, reading command. Number 2, making copies. Number 3, reloading paper. Number 4, diagnosing problem. Apart from user's input, there can be other events which can change the state of the software. For example, copies done, paper reload complete, paper jammed, etc. A simplified state transition diagram for the photocopier software described above is shown in figure. When photocopier machine is started, it is ready for reading user's input. If user inputs the command to copy, system goes into copying state if papers are available. If during copying, papers finish, system goes to reload paper state. When reload is complete, system goes back to initial state of reading command. If user gets the command to continue the copying job, system will re-enter the copying state and will keep on copying till the job is finished, and it notifies the system that job is done and goes back to initial state of reading command. While copying, paper can be jammed in the machine. In that case, system will enter the diagnosing problem state. When the jammed paper is removed, system will go back to reading command state. If user wants to continue with copying job, system will go back to copying till the job